from particulate chromate exposure does not inhibit homologous recombination repair in North Atlantic right whale, Eubalaena glacialis. And prolonged means taking for a long time, and exposure means staying in a kind of environment. And inhibit means to decrease or to stop end reaction. And right whale lives in North Atlantic Ocean, near the South United States. And to talk about our main issue in this research is chromosome instability, which means chromosome unstable. And the chromosomes is inside this cell is nucleus, and inside the nucleus we have the DNA message, which is stored into chromosome. So this is chromosome, and if the chromosome becomes unstable, it will easily to get damage or break, so the cell becomes cancer. And what is homologous chromosomes? You know, every one of us have 23 pairs of chromosomes. Each pair has 2 chromosomes. One is from your father, and one is from your mother. And during our growth, our cell have to divide from 1 to 2 cells. So there is a stage we call metaphase, that all the homologous chromosomes line up together in here, and we call this stage metaphase. And in this stage, if the chromosome already unstable, it's easy to get damage, or the part of their DNA sequence will exchange like this, and we call this sister chromatid exchange, so as SCE. And it also will happen the chromosome break like this, and we call this plastogen. So I will just call it later DNA damage. And then we talk about the toxic material. In our daily life, hexavalent chromium products, this is hexavalent. Hexavalent means 6 bonds. So it has 6 bonds can bind to other chemicals. And this stuff, this material can be used on preventing our stuff from getting rusty. So the metal will become rusty if it exposure in the oxygen. So we use this products, then we can prevent things from getting rusty. And because this is common use in our daily life, it already polluted our water resource and causing humans to get lung cancer. And this toxic material causes the chromosome instability, above I say, and also inhibits homologous recombination repair, which is HR repair. Then what is homologous HR repair? It's a kind of protective DNA repair, which means we use a healthy DNA to repair, to fix the broken DNA. And these 2 pairs of DNA have to come from homologous pair, and with RAD by 1. Then what is RAD by 1? It's a number of a part of DNA sequence. This is a protein. The protein encoded by this part of DNA sequence, and they are related to HR repair process. So if we know the RAD by 1 response, then we can know whether the cell is working on HR repair or not. So this is the target of this research. And then in this research, our purpose is we want to find out the effects on different chrome exposure time. In previous research, they have already known more prolonged exposure time will inhibit the HR repair in human cells. So what about right whale? We assume that more prolonged exposure time does not inhibit HR repair, so I hope to convince this. So how we do our research? We collect the cells, the right whale lung cells, because of lung cancer, from stranded right whale. This is stranded whales. And we control the environment in 33 degrees Celsius and separate into 2 groups for different prolonged exposure time. One is 24 hours and the other one is 120 hours. And then we add zinc chromate. This is zinc chromate as the toxic material. And we store the cell in a metaphase situation, this state, and then we add the API. It's a kind of medicine which is 4,6 that may denote 2 billion window, and the structure is here. And this medicine can mark our RAD51, make them glow in the dark like this. So help us to easily observe. And this is my first part of my data. The x-axis is zinc chromate concentration and y-axis is relative survival. So which means the more concentration because the cells die, so the survival becomes less. And the black one is 24 hours, gray is 120 hours. So you see 24 hours is more than 120 hours. But the difference between them is small, not significant. So we say more prolonged time does not significantly decrease relative survival. And the second one is x-axis is zinc chromate concentration, y-axis is percent of metaphase with damage, and this is total damage. So with more concentration, more cells get DNA get damaged, so it decreases. And between 24 hours black one and 120 hours gray one, 24 hours is more than 120 hours. So we say more prolonged time does not increase damage. And then the third one, this is RAD51 response. X-axis is zinc chromate concentration, and y-axis is the percent of cells with more than 5 RAD51 foci. Foci means a group, and a group that many RAD51 gather together. And so we call this group a foci. If there are more than 5 foci, then it will appear on this data. So you see in this picture, 1 to 2 hours has the lower value. And then we see the right pictures. This is RAD51 response. And this is after you add the API, so it's glow in the dark. And merge means combine these two data combine these two pictures into this picture. So in this picture, dark, if the picture is darker, it means the RAD51 value is more. So the result is the same. The more prolonged time decrease RAD51 foci. And then the lower part, this is sister chromatic exchange. This is x-axis is exposure time. This y-axis is zinc chromate concentration. In both concentration, they both have SC happen. This is SC. And the data x-axis is exposure time. Y-axis is SC per metaphase and SC per chromosomes. And different colors means different zinc chromate concentration. So you see 24 hours, and between these two data, their difference is small, not significant. So we say more prolonged time does not increase sister chromatic exchange. So of all this data, we have a conclusion that omic damage and RAD51 foci has an obvious value that 24 hours is more than 120 hours. These two are not significant. But it still can support our result that you see, although the RAD51 foci value in 120 hours is low, but it still can fix the damaged DNA into the healthy one. So you see the damage in 120 hours is lower too. So it means the HR repair is still working on. So the result, more prolonged time does not inhibit HR repair, it writes well on cells. And we hope that if we can investigate this research in the future more, then maybe one day human can have the ability of preventing from getting cancer. Thank you for your attention. 9 minutes, 40 seconds. Okay, you ready? Sam. Vincent.
Benson. Hints. Tony. Alright, so starting from Sen. Come back to you later. Vincent.
Not really用的picture first you say is mix API and RID try to do that.
Repeat.
Oh, why in this picture we combine the API and RD by one response? Okay. I don't know, because all the cancer research will do this process. Yes, but I don't really understand the detail. Sorry.
Second would be Benson.
Why in this research get a cell sample from the stranded right well?
Because
Repeat this question.
why I get the cell from stranded right whale? Yes, because right whale is already an endangered species, so we cannot capture them for research. To kill them is not good for environment. So we collect it from stranded animals because there already have been much whales stranded. Okay.
Next would be Hint.
How do you keep your cell in metaphase?
Oh,
Repeat.
how do I keep the cell in metaphase state? We have a medicine, but I didn't put it here. And the medicine will combine to, when during the metaphase there were material products in this state, and the medicine will combine to the material, make stop in the metaphase. Inhibit the metaphase to go further. So we'll stop right here. So we can store the cells in the metaphase station. Okay.
We usually say medicine.
Oh.
Tony.
Many files in the picture and this cost 24 hours and another 20 hours. And if other other back to your intent and tonight and the first 24 hours have some, but not the same with all of them.
We could ask is before before we collect the cells, is the cell already been polluted? Already have some problem. Right?
You were asking something about exposure time. Can you repeat your question again?
Oh, yeah. I say with time and the environment or the environment will the same.
Oh, you say will this happen in the environment? Okay. Please repeat again.
I'll come back to you later. Sid.
Do they get used to toxic substance because the damage to the RAD51 become low?
Please repeat.
Repeat.
do they get used to toxic substance because the damage to the RAD51 become low?
Do you get it?
Please repeat again. Louder. The last word you said. The last word you said.
Become lower.
Become lower.
Lower.
LOW.
Is there any specific slide you are referring to? Some slide, data slide? No? Where did you see RAD51 in your?
You said why the RD51 value is lower in 1 to 2 hours? Is that it?
Yes.
We didn't figure out the detail in this result. We just get the data.
And
And
what
then
was
make
your
a-
inferred interpretation? The first part of the sentence of your question. Can you read again the first part of your question? Do they?
Do they get used to toxic substance?
Do they?
They get used to toxic substance. I think the answer is no. We didn't know the detail, but the toxic material will make the chromosome become unstable. But I don't know whether it will get used to it or not.
Tony,
Whether and environmental and how they control the
Oh, we take
go
the
back to the slide.
okay. So you say, how do we control the environment in the 33 degrees? The experiment is working in a laboratory. After we collect the cell, it is not in a. There was a machine that can control a certain temperature. Is that your question? Okay.
Okay, I'll come back to this point later. Volunteer question we can have for two. William and Win and okay. Okay. William.
Why do you choose the lung cell?
Oh, because why choose the lung cells? Because this toxic material already affect human lung cancer, so we choose the lung cells.
My question is similar to Tony. You have taught that you control in 33 degrees. So, are the 33 degrees are the most suitable to maintain a cell, or the lower degree will affect the result?
Oh, okay. You asked if the 33 degrees is the comfortable, the good temperature. We use 33 degrees because the whale's body temperature is 33 degrees. So we use 33. That is.
That's all, right?
In common situation, we've been more are exposed to the chocolate. I think it's worse, but you say that under 20 hours or not worse than 24 hours. I wonder why is the reason.
You mean our results? we don't know yet. We know the answer that we hope we can find out why in the right blood lung cells the value in 120 hours will lower. Maybe one day human can prevent cancer. Yeah.
Okay, listen. Okay, so regarding this note, so first of all, I have to comment that so at the beginning she made enough preparation work for the audience. So I think starting from this one to this one, at least. So she spent almost 10 slides explaining, preparing you in order to understand her talk. So I guess most of you might have a good understanding of what she was talking about. So which is a really good job. So as I mentioned many times, if you are going to talk about molecular biology work to the general public like you, then the only way, I would say the only way is cartoon. Okay, so you have to prepare enough cartoons. Okay, and then most of her slides have very few text. Okay, like this one. So it's easy to follow, but that really relies on good presentation skills. Okay, and large font. And then there was a clear purpose slide, although I would say the motivation was not clear enough. I will talk about it later. And she spoke in a clear way, but regarding her time control fail, I would say maybe you can spoke a little bit slower. Okay, and then the concluding remark was, I like this table, although I also got a bit confused. I will talk about this later. Then weakness. So I think regarding the how fluent you spoke, you should be able to look at the audience next time. And I think the reason, I think that's related to William's question. So you chose lung cells, and then you mentioned that because that's a cause, this chromium substance is a cause of lung cancer. But you probably need to tell us why you chose to compare, or why, because we are more concerned about cancer in human beings. Why should you choose this creature that seems to swim happily in the ocean and far away from the chromium substance, seems like, okay? So you need to tell us why, okay? And then, so that's the thing regarding motivation. And then there were some questions regarding this slides. So I think one missing link is you probably say that, but was not clear enough. So I think Tony was thinking, oh, you were doing your experiment on the beach. So you need to control the beach at 33 degrees, and you expose the dead whale body for 24 to 5 days, something like that. So you really need to say clearly. Maybe the best way is you put all the information here to another slide, and then you put a picture of laboratory. Then it's clear, okay? So I think that was a misunderstanding. Okay. Then, regarding the presentation of data, I think they are all well done. But the thing at some point I started to get lost. So imagine that you do this research in order to know more about cancer treatment. Okay. So maybe you at this conclusion slides, you should give us some interpretation. So this means, does this chromium substance damaging the cell more or less, something like that? Because the high signal means it's repairing, right? And the low signal means not repairing. But here you say the damage is high and low. I think you need to give us a clear logic. So how does that link to cancer treatment? Okay, but otherwise I think it's a very clear and good presentation. So let's thank our last speaker. So next week we expect 5 talk to Vincent, Jake, Win, Paul, and Angelica, and I